So what is WMS layers? So WMS layers stand for Web Map Service. This is an OGC standard way of sharing data. Let's say you are a data provider. You collected some nice data. You say, I have this amazing land cover classification for the entire world, and I want to share it with you. You might say, I will create this gigantic GeoTIFF file and share it with you, or I will chop it up to small tiles and I can share it with you. But then to even look at the land cover classification for your region, you have to download data, you need a GIS software and so on. Instead, you can say, I will publish a service. You don't need to actually download the data. You can connect to my server and see it on any supported client. There are so many different clients that allow you to access WMS layers. So I can give you that, and you don't have to really download data, work with it. You can just consume the data as a service. When I update this data, let's say I have data that updates every day. You don't have to come to me every day and download the data. Your service will automatically update. So in theory, it's a great thing, a great way of distributing data. Let's see how the WMS service works. Everybody who publishes this data, they'll give you a URL. This is our server that is publishing WMS service. GeoServer is a very popularly used server. So we are using this service from CDAC, where they're distributing a lot of data using this. They're using GeoServer, QGIS server, Map server. There are many servers. All of them publish WMS data. Even Esri servers publish WMS data because it's an open standard. So regardless of the technology used, the standard is the same. You can consume this data. To consume this data in QGIS, we have to come here. That is the Open Data Source Manager. You can see it can load the WMS layers. I can say I want to configure this data. You can see this is my URL. I can configure the name, and I can say connect. Don't have to do it, just learn what WMS is, so we can kind of learn how to work with them using QGIS. And you can see this service publishes so many data assets. There's a database of, nuclear power plants. There's some, biomes and all of the data sets. So you can kind of load this data into QGIS without having to download this as a service. And you can see my service is frozen. I did something which I didn't like. And again, that's why WMS services are a bit painful to work with and slow. So if you want to use this, you'll always have to be connected to the internet. What if you're going offline, or what if you're working in a place where there's no connection? So let's first search for, I'm going to search for this layer called reservoirs. There is a data on reservoirs that they distribute. So this is reservoir data, global reservoirs data. So if you select this, you can say add. And when I click add, you can see I see a map here. I can zoom in to any place, and you can see it's fetching new data. And this is not like the cloud optimized GeoTIFF one. It's not coming from a file. There'll be a file somewhere. It's going through a server. A server is creating a visual tile, a PNG tile, and send it to you. So there's a server in between, sitting between you and the data. You zoom in, it's going to find the data at that location. And you can kind of see, okay, this is the reservoir boundary and so on. And so nice data, but again, if you don't have internet, this will not work. So you can use this. Now, let's say you are going somewhere where you don't have internet connection, or you say, every day I need to work with this reservoir. I wish I can just download this, have it locally. Can I do this? One option for clients like QGIS, you can say right click, export, save as. If you do this, you can say the raw data, you can save it as GeoTIFF files. You can give an extent, it'll go and download the data at whatever resolution you specify here. So for just one place like this, you can say, go and download this data. What if you want to download for your entire country? It becomes difficult. You have to kind of right click and do all of that. GDAL now understands WMS data as one of the data sources. So if you have a WMS data source, you can now treat them as just another raster. So you can do GDAL info, you can do GDAL translate, you can do GDAL warp. It just becomes another data source. In GDAL, you can say GDAL translate, my original file is this WMS file, convert it to a GeoTIFF file. And it's going to do all of that. It's going to find the data, stitch it, download it, georeference it, and you have a local GeoTIFF file that you can use. Super helpful when you want to take it offline, or there are servers which are quite unreliable. You want to do your work, but the server is down. Well, you can download this offline for your own use. Okay, let's start working with WMS layers. Go ahead and copy this command from section 1.5.1. We'll see how to use WMS layers using GDAL. When you go to a WMS service, you'll get a URL like this. This is the URL to access the service. So we'll just prefix WMS : This indicates to GDAL that this is the WMS layer, and then we can run GDAL commands on that. So let's run GDAL info on this. On your terminal, we can just do cd double dot. So we can come out of the Lancet 8 folder. We're just working on the root Lancet, root GDAL tools folder. And we can do this GDAL info, WMS, and then the WMS URL. So go ahead and run this. When you run GDAL info, it says this URL has so many layers. This WMS service publishes more than 200 layers. So when I run this, it says these are all the layers that are published by this service. You can see there are sub datasets, or there are now actually 563 sub datasets. There are 563 layers that are published by the service. And each service has a URL. You can see this URL is specific to that particular service, and you can use that. Right? So you can go and see all of these different layers that are published by this service. We saw that this is quite a lot of information. When you have sometimes information that's printed by in a very long way, you can say greater than and some file name. So I can say greater than, and I'll just say wms.txt. Greater than symbol will say whatever is the output of this command, save it to a text file. So I can do some search and I can do something else. So now when I run this, you'll see that this went to a text file. I can open the text file however I'm comfortable with, and then I can go and search data. So I can say here, I have wms.txt. I can open with my favorite text editor, and you'll see just a text file containing the output of the command we just created. And now I can see and search and browse through that. Right? A useful tip if you work with commands, you want to save the output. Greater than symbol sends output to this. Here, what we want to use, we want to search for our reservoirs layers. So you can see this is the sub dataset name, reservoir. So you can see this is the layer that we're interested in, global reservoir and dam database. So we want to say, I want to, this specific layer, I want to download that as a GeoTIFF file. That's our task. So we first did GDAL info on the server. Server said, I'm serving so many datasets. We saved the output to a text file, and then we got the URL pointing to the specific dataset. So this one is the reservoir dataset that we found it. So I can copy that and do GDAL info on that. That's your next command. If you've not done the saving to a text file, you can just copy this command here, GDAL info, and then this is the part that we found from the server output. And I can run that. You can say GDAL info, this. And because the string can contain a lot of special characters, make sure you put double quotes around that. And now we can kind of see this information similar to a typical GDAL info output, where it says, this is the WMS web service. This is the projection of the data. Pixel size, this is very, very high resolution. Why is it very, very high resolution? Because the original data is actually a vector data set. The underlying file is actually, will be a vector shapefile, polygon file. When you serve WMS, they are rasterizing it on the fly and sending the data at whatever resolution you ask for. So you can ask the data at whatever resolution, and you can see this is the visual data. You have red, green, and blue channels. So they are colorizing it and sending the data. One of the reasons data providers like WMS, because then they don't have to share the shapefiles with you. They say, we'll keep our shapefiles, we'll send you colorized version of that, which you can see it, but you cannot use it in your analysis. There are people who do not want to share their raw data openly. They'll publish this WMS service. You can see it, but you can't use it in analysis. So that's why a lot of this underlying data for WMS services are vectors. And when you ask the data, you can ask it any resolution you want. So now we have this data source. This whole thing is like a data layer. GDAL understands this just like a data layer, and we can run our GDAL commands. So now if you want to do anything with this data, you can take any GDAL command that you learned and apply it. Let's just apply the file, apply the command that we learned to transfer this data. But I want to teach you one of this other really interesting formats. This data set that we are using, it's a URL. So this URL describes the service. You can actually turn this into a file, which GDAL tools and other services will understand. So let's run the next command, which uses GDAL translate. The output format, we are saving it as a WMS format. This is a format which describes the WMS data as an XML file. So let's take this data and save it. I'm going to show you what this file looks like in a second. So this is whatever these URLs contain, put that information into this XML file. This is section 1.5.2. This XML file is known as a service description file, which describes what the WMS service is serving and what specific data layer that you want. This file contains all the information to connect to the server and get the data layer that you want. So instead of you manually going to QGIS, configuring it, picking the layer and opening it, you can send somebody this XML file, and any software that understands GDAL will be able to just connect to the server and load this. So I'll show you how that works. You remove all the data, and from a GDAL tools, we just created this reservoirs.xml file. It's going to drag and drop it into QGIS. And you can see my reservoirs layers just loaded. So this file contains all the information to connect to the server and load the specific data layer that we had selected. So if you want to just create this file and say, hey, connect to this server, you don't have to write instructions for your colleagues saying connect to the server, select this layer, load this, send them a file, they can drag and drop it, and you can now have all the information to connect to the server. So this one file is enough to connect to the server. And again, we can use this file as an input and say, take the service, whatever is contained in the XML file, translate this into another file format. So quite helpful. A lot of people who are building QGIS plugins or working with QGIS, they say, we want a button. I want a button here. Click this button. It loads this WMS service. Well, you can just put a file in your plugin and call this file when you click this button. It just loads the WMS service. Makes it super easy to load to different custom services by just putting the information in this WMS files. And now we can do the next step, which downloading WMS layers. We can do it two ways. If you want to download it at specific resolution, you can use GDAL warp. So you can convert that original pixel size into whatever pixel size you want, and then translate it to any other file. So let's try this 0.5.3. We can use the GDAL warp command. And this command says my target resolution, the -tr says the target resolution in degrees. 0.1 degrees X resolution, 0.1 degrees Y resolution. Take the layer that I'm describing in this reservoirs.xml, convert it to a reservoir.tiff. Now we are creating a TIFF file out of this and run this. This is now sending those WMS requests to the server in the background, collecting all the tiles that you need for creating the file, stitching them, and outputting this particular file. And when you have the reservoirs.tiff, you can load this in QGIS, and you will see that now it doesn't go to the server. It's just the data that is sitting on your computer. We took the data from the server, and now we have a georeference TIFF file that we downloaded to our computer. For the sake of speed, we're just doing it at a very low resolution here, but you can ask the data at any resolution. If you ask it at very high resolution, it's going to take a while for it to fetch all the tiles, stitch them together, and create that. But it's a one-time process. Once it's done, you can always use that file without having to go to the server. Also, be mindful of the server. I didn't want to put too much load on the server by sending, 20 requests at the same time from the class. So we are doing it at a low resolution. If you're doing this, maybe do it at a time where the server is not too busy, or do it in small chunks so that you're not putting too much load on the server. Let's go to GDAL warp, and I want to show you. So GDAL warp is the command that we use to extract this data. We had specified this -tr for specifying the resolution of the output data. And as we learned, this is coming from a vector-backed dataset, so we can specify as high resolution as possible. As I mentioned, sometimes when you are trying to download this data, you don't want to put too much load on the server. So we can say, I want to download this at a very high resolution, but only for my region. So you can specify this option called -te, which is saying that what is the region or a bounding box of the region that you want to specify. So I want to say I want the georeference extent of the output file created. So you can specify the coordinates, the xmin, ymin, xmax, ymax, and say download data only for that region. And it'll only create the data for that output. Okay, so let's see how we can use this -te command. In the next step of 1.5.3, we have the command here. So GDAL warp. Now, my resolution is very fine resolution, 0.005 degrees. So very fine resolution, but I'm downloading data only for this extent. This is the extent for India. So I can say, take my XML file, which is describing the reservoirs for the entire world, but download data only for this extent. It will save me to reservoirs.india. So let's run this. For now, just run it like this. You can later change it to the extent of your country or of region of interest. And you can see it's now fetching those tiles in the background, collecting those, stitching them together, and it's now downloading this data as a high resolution TIFF file for your region. Let's look at this data first. Reservoirs India. If I load this data and zoom to it, you can see now this data is quite higher resolution than before, but you can see the extent is only for India. So I could now download a subset of the data, stitch it, and create a GeoTIFF file.